Hello everyone. On the last class we talked about some calculus review and also some Taylor polynomial and error estimative. On this class we are going to start with some linear difference equation theory and applications and a brief linear algebra review. So to start this class, let's think about cell division. So how does it happen? So you have one mother cell that splits in two, and then we get two cells, which after a while they also split themselves, which gives two cells each one of them. So here is on the time, let's call time n, discrete time, n equals 0. Here n equal 1. And here n equal 2. And if you want to know how many cells we are going to have on the time n equal big N. So considering that in the beginning we have one cell, and this one cell splits into two, so it will be 1, then times 2, times 2, and yeah, so here in this n equal 2 generation, we are going to have in the end 4 cells. Applying the same thoughts, we could say that in the time big N, the total number of cells, at time n, it will be 2 times big N times, here in this case initially we have 1 cells, but we could have more, so 2 to the big N times 2, let's call here C0, then the initial number of cells. So let's see how this concept, how this model is important, relevant to many other kind of problems and applications, and how we can try to solve this problem using linear algebra approaches. So, as I said, suppose that a population of cells divide synchronously, which means that they divide everyone at the same time, and each one of them produce a member producing a daughter cell. So A here is in our previous example, A, it was equal to, so each cells produce A daughter cells. And also the cells, the mother cell also doesn't exist anymore in the next generation, which means that the cells just split itself, okay? So we can write a simple equation to model the number of cells in each generation. So in the generation n+1 here, it will the number of cells in the next generation will be the number of cells in the previous generation times the number of cells that each cell generates. Okay. So if we suppose that initially there were M0 cells, how big will be the population after n generations? So we can apply this same thoughts here, and we can get that on the generation n+1, we are going to have A times A m n minus 1, which is the number of cells that existed in the past generation, and so on. So we get that this will be the amount of cells in the nth generation. So m n+1, it will be A n times m0. So if we look at this equation here, we can say what we can say about the growth of the population. So if A is bigger than 1, mn at the time n will increase over successive generations, which makes sense because here m0 is some number bigger than 1, because the cell cannot be half a cell. And then if we have a number here bigger than 1, that is having this n exponent, then it on the generation n+1, the population will grow. So if A is less than 1, the population will decrease over successive generation, and if A equal 1, m of n, which is the number of cells in the time n, will be constant. Okay, yeah, so m of n will be the number of cells at the time n. Okay. Okay, yeah. So let's try to write this approach mathematically. So this kind of equations, they are called linear difference equation of first order. We are going to see what does it mean, and it is related to only to the last one generation. That's why it's first order. Okay, so the general solution of this kind of equation is given by this, where c is bigger than 0 is a constant. So the objective here in this class is try to solve difference equation by using some techniques from linear algebra, at least the linear difference equations. So this is the solution of this equation. So if we get our equation and we substitute this, so here n plus 1 it will be then C times lambda n plus 1, right? So then we substitute this here, and also substitute for mn. So we get this, and in the end we get that lambda should be equal A. So we find that this is the solution of this equation. So another question would be how to determine this constant C. Think about that. We can discuss it. So remember that we know that C should be equal m0. So try to use this assumption here, that the solution is like this, and then substitute here, and see if you can get that C equal m0.